Hello, this is Mrs. Myers. Today we're going to learn lesson 12.1, tangent lines, tangent to a circle. Our objective is to learn what a tangent line is and what properties and values it creates in respect to the circle. So a tangent line that is tangent, when we say it's tangent to a circle, it's a line in the plane that has one point in common with the circle. It's just barely skimming the edge of a circle. The point of intersection, or the point of tangency, in this diagram would be point P. So we call that one point that they have in common, the circle and the tangent line, we call it the point of tangency. It's the point of intersection. You may have heard the term or the phrase going off on a tangent, like if we're in class and you try to get me talking about something that has nothing to do with geometry. That's called getting off on a tangent. It's kind of related to this tangent line thing, because if we think about, why does this always do this to me? Okay, go away now. If we think about the circle as being the subject that we're trying to stick to, meaning geometry, and then you guys get me talking about something that maybe there's one thing in geometry that reminded you of this topic, but then we get off on a tangent. The rest of it just really kind of skims the surface. So I think that's where that phrase comes from. Okay, we have a few theorems here, really two basic theorems. The first one says if a line is tangent to a circle, then it's perpendicular to the radius at the point of tangency. So if you have a tangent line and you take that point of tangency and you draw a segment from the point of tangency to the center of the circle, you've created a radius. That radius is perpendicular, meaning it's got a right angle to the tangent line. The converse of this is also true. So our second theorem out of three, the second theorem, is just the converse of the first one. So notice here it says this is the converse of the first theorem. And it just says if you have a line that is perpendicular to a radius with an endpoint on the circle, then the line is tangent to the circle. So in the first case, we have a circle and we're told this line is tangent. If we're told this line is tangent, we are able to draw a radius and know that it is perpendicular to the tangent line. So here we are given the circle and we're told that the line's tangent. Down here, we're given the circle and we're given a radius, and then we're told this line is drawn so that it's got one point to the radius. Therefore, we can conclude, okay, well then it must be a tangent line. So basically, the given information up here is that the line is tangent. That's given. The line is tangent. Given the line is tangent, we can conclude there's a 90-degree angle, right? Perpendicular. Down here, we're given that it is a 90-degree angle. In other words, it's perpendicular. We're told that it's perpendicular. That's given information. And over here, then that means we can conclude, okay, then it is a tangent line. Okay, so it's just the converse. If you remember, it kind of switches the if and the then. So that's one, I'm kind of counting that as one concept. The two theorems that are converses of each other, that's one concept. So basically what we can take away from this, the basic takeaway is this right here. So when you are given a tangent line, immediately draw in a right angle. Okay? And if you have a right angle there, immediately you know it's a tangent line, you can do anything with that. that we know with tangent lines. Okay, so the second concept that we really need to use here is that the theorem that says if two tangent segments to a circle share a common endpoint outside the circle. In other words, we draw one tangent line, and we draw from that same point outside of the circle, we draw another tangent line. Well, then there's two segments that are formed. One from that vertex of this angle that goes to one point of tangency, and the other one that goes to the other point of tangency. When you have this situation, what you want to do is immediately recognize this situation and mark these things congruent. So you're going to have the circle, you're going to have a point outside the circle, and a tangent line drawn to two different points of tangency on the circle. I didn't draw that perfectly, but it's supposed to just go right there. Whenever you see this situation, mark these congruent. Those are automatically congruent. All right, so what does this look like in problems that you might have to solve? Here's some practice. So we're told that ED is tangent to circle O. ED is tangent to circle O. So again, immediately that tells you when you see the word tangent, you think right angle, 90 degrees. Okay, so if ED is tangent to circle O, that means that ED is perpendicular to radius OD. So now we're trying to solve for the value of x. Well, in this case, we're just really looking at this triangle. We know it's a right triangle because of that word that says tangent. And we know this is 38 degrees. So we're looking for the missing angle. We know that 90 degrees is the right angle, plus 38 degrees, plus the x has to all add up to 180 because of the triangle sum theorem. So when we add this up, we get 128 plus x equals 180. And we're going to solve for x by subtracting 128 from both sides. And we get x equals, oops, that's an 8, 52 degrees. Okay, let's look at number 2. ML and MN are tangent to the circle. So now we've got two segments that are tangent to the circle. See the word tangent and think right angles. So we can mark those to be right angles. What's the value of x? We also, in this situation, we could mark these congruent. It doesn't end up helping us solve the problem, but we could mark them congruent because of that second concept, that theorem. So this is forming a quadrilateral here. And we know that the four angles of a quadrilateral have to add up to 360. So we're going to do 90 plus 117 is given to us here, plus another 90, plus x is the missing, equals 360. If you forgot that it was 360, remember that when you have any polygon, 180 times n minus 2 is the sum of the measures, the sum of the measures of the angles, the interior angles. So 180 times this has, n is the number of sides, this has 4 sides, so 4 minus 2 is 2, so this is 180 times 2, or 360, for a 4-sided figure. Okay, so then we could solve this from there. I'm actually not going to work this out right now. You can work that out yourself, and we'll come back and check those answers at another time. Let's look at number 3. What is the radius of circle C? So we're looking for the radius. Well, we are told that from the center C to point B is x. We're told this is a right angle, so we know that this is a tangent line, and we're told the length of AB is 12. We are told that from A to the circle, this is meant for this 8 is just going up to here. That's 8. And then from here to here is x again. it has to be x. If this one's x, this has to be x. Because remember, all radii in a given circle are congruent. So equidistant, right? All of these on the circle are the same distance from the center. So all the radii have to be congruent. Okay, so if this radius is x, this has to be x. Well, then we have this triangle. So we have this whole side. We have to write an expression for that. If from here to here is x, and from here to here is 8, then the whole side is considered x plus 8. So now we've got three sides, the three sides of the triangle. It's a right triangle, and we can use Pythagorean theorem. X squared plus this whole side is x plus 8 squared. Oops, sorry. Got to do the two legs. X squared plus 12 squared equals the hypotenuse, x plus 8 squared. So we've got x squared plus 144 equals, now don't forget this, talked about this before, this whole thing to the second power means the whole thing times itself. Do not try to take a shortcut. You have to do FOIL here. You have to distribute, multiply everything out. X times x is x squared. X times 8 is 8x. 8 times x is 8x again. 8 times 8 is 64. So we end up with x squared plus 144 equals x squared plus 16x plus 64. I know you're thinking, uh-oh, do we have to factor? But this one we don't, because we're just going to subtract x squared from both sides. And that gets rid of the x squared on both sides. Then we can subtract 64 from both sides, and we get 80 equals 16x. We're going to divide by 16, and we get x equals 5. It doesn't have any units here, so x is just 5. Okay? So, the three problems that we did, here we involved the triangle sum theorem, all the angles add up to 180. Here, the quadrilateral sum theorem, right, which basically says they all add up to 360. And here we use Pythagorean theorem. With right angles, there's a lot of things that we know how to do and we know how to solve for. So this one says ML is tangent to circle N. Oh, it's asking, is ML tangent to circle N at L? So they're asking, is this tangent? So really we're asking, is this a right angle? So we could use the Pythagorean theorem to test to see if it's a right angle. If you remember doing that. Check and see, is 24 squared plus 7 squared equal to the hypotenuse 25 squared? Check and see if the Pythagorean theorem works. I'm going to give you a minute to do that and then come back. Okay, hopefully you tried that on your own and you got that 576 plus 49 is in fact 625, which is 25 squared. So yes, it's a right angle, so it's perpendicular, therefore it's tangent. It's perpendicular, therefore yes, it's tangent. If it's a right angle, it has to be tangent. Okay, number 5 says circle O is inscribed in triangle ABC. What is the perimeter? So if this is inscribed in here, what is the perimeter? We are told that from here to here is 10. Remember, that third theorem that we learned in the beginning of this lesson said if you have a point outside of the circle, there's these segments that are formed to the points of tangency. Immediately mark those congruent. So if AD is 10 centimeters, then AF has to be 10 as well. Same thing down here. We have got a point outside. It's tangent and tangent. If this is 8, then this has to be 8. And then the last one, the point outside is B. From B to D is 15. Therefore, from B to E has to be 15. This was that last theorem that we did on the first page down here, right? Immediately mark these congruent if you have this situation where there's a point outside of the circle that's connecting to tangent lines. So then we should be able to find perimeter. Start at point A. We go A to D is 10, plus D to B is 15, plus B to E is another 15, plus E to C is 8, plus C to F is another 8, plus another 10. So that's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 numbers we're adding up here. So 10 and 10 is 20, 15 and 15 is 30, and 8 and 8 is 16. So we got 66. 50 and 16 is 66. So 66 centimeters. Okay, so these next few problems are some that I would like you to try before class tomorrow. And so let's do 1 through 8. Okay, do 1 through 8 by class time tomorrow, and we'll look at the answers then. Okay, thanks.